All right. So this week's lecture is going to be on decision making and problem solving. We've talked a lot about the pieces that go into decision making, but not some of the theories or methods that are about decision making as a whole. So some of the core things I want us to get out of this, I want you to be able to describe how humans make decisions, summarize and compare different decision-making models, explain how System 1 and System 2 thinking affects decision-making. You should be able to give examples of decision-making methods, apply decision-making principles to industrial operations, and present how decision-making can fail and lead to poor outcomes. Like I said, we've already done a lot of this, but this lecture will kind of tie together some of those pieces. Also, every time I load up one of these, it changes my fonts and messes up everything there. So, okay. So when we're thinking about decision making, and this I kind of just framed as operations, but and remember when you think about operations, we want to think about that in kind of a generic sense. Everything in essence is some kind of an operation. So in that sense, everybody is an operator of some kind. So operators must develop a response to a world state under uncertainty. It's under uncertainty because we don't know everything about the world at any given moment. Um, and that's where we get into a definition of risk. Uh, so the definition here, right? A commitment to a course of action that is intended to yield results that are satisfying for specified individuals. Um, so we could also call this, a commitment to a course of action is intended to bring about a goal, to modify the world state in some way, and then obviously you can specify that to, a commitment to drive to the grocery store. So we're looking at macro level decision making and response planning. That's this section here of this broader aspect. Again, it doesn't have to be nuclear specific, but we are pulling in a cognitive model of nuclear power plant operations uh, just because it's uh, well separated and kind of gives us a good understanding there. So now we're getting into decision making specifically. So the adaptive decision maker framework, it's evaluating alternatives and making choices between them. The framework steps are identify the decision, gather relevant information, identify alternatives, weigh the evidence, choose among alternatives, whoops, take action, and review your decision and its consequences. This seems like a lot of, atomistic steps, but if you break down any decision that you've made, the simplest one, you are doing these steps in some fashion. And, that's why we said it can be as small as we want, or it can expand to accommodate whatever we need there. All right, so some decision making paradigms, or these are just kind of, as we're going through these models, we'll separate these. But, when we talk about decision making, we're generally saying one of three things. We're either saying what should we do or what ought we do. These are normative models. They're normative because we're attaching a normative or a value judgment on decisions, alternatives, whatever. So that's a big thing, when we read the news or criminal justice and stuff, right? What should have happened, and that's where we get to our sense of right and wrong and those kind of things. Typical, when we're looking at ethics as a concept, that's going to be generally normative decision making. Now, descriptive models, a little bit different. This is what do we actually do? So, descriptive models are an attempt to uh, kind of describe or interpret decision making in a way that aligns with reality. Uh, and then naturalistic models are most representative of experts in the real world. So one interesting thing people might think is, what's the difference here? between descriptive and naturalistic. Typically, naturalistic models are dealing with expert populations, complex tasking, those kind of things. But it is possible, right? There may be room there to argue that about you don't, you know, whether it's an expert or a novice doesn't actually change the reality of it. Then, okay, so normative decision-making models. So remember, this is what ought we do. This is classical decision theory, and we're not talking about it here, but this is ethics as well. So earliest models are going to be economically grounded. They're on what should we do to maximize some good, some utility, value, whatever. Expected utility theory is the kind of foundational one. This is people should act in a way that there's a greatest utility, and people make those decisions. Then we got the economic man and woman theories in the 50s, and this underpins a lot of economics, even now. If you've taken classes in economics, you will have heard, if we assume perfect rationality, perfect uh, information, and those kind of things, then those models, as you're learning some economic models, you need those assumptions. And so the idea is, they're fully rational, another typo there, always select the optimal option. And it describes how decisions should be made. And the biggest criticism of it is not representative of how decisions are actually made by people. And obviously, this is all the economic side. There's a whole separate realm on the ethics side of things about how we ought to do, what actions we ought to take, what do we value, and how do we ground that. If you're interested in that, let me know, and I can point you in the direction of the philosophy department. So descriptive decision-making models, this is, remember, what do we actually do? So we've got Dan Ariely's work has been pretty formative there, but also we can look at Freakonomics. If you have heard of that book, I believe it was a documentary or something that you might be able to find on YouTube, but Freakonomics was kind of predated Dan Ariely's work. So descriptive decision-making models attempt to describe how decisions are actually made. Decision-making under risk, so under uncertainty, right? We do have some, we can think of instances where we may be able to make a decision without risk, or we do know everything about it. For example, if I lift, let's see, I've got a pen on my desk and drop it, I think I could make that decision to drop my pen on my desk without risk or uncertainty. I know it's going to happen. But the majority of our decisions involve some aspect of risk, uncertainty, and imperfect knowledge of the world. Bounded rationality is one big theory that undergirds a lot of descriptive decision-making theories. So this is the notion that, let's see, let me get rid of some of these. Whoops. Sorry, I gotta scroll back because now it's in the wrong spot. Okay, and then let's get rid of, see, this keeps happening. Okay, so bounded rationality is this instance. It comes from Simon, 1957. I would argue Descartes did this long before. Let's say this little dot is you. This circle is your knowledge, experience, the things that you know and can be reasonably expect to know what to do within that sphere. Now, let's say you exit and you want to take an action out here. That is outside of your rationality, risk of errors, different things like that. Bounded rationality is kind of speaking on those aspects. We also are looking at subjective expected utility. So subjective utility is the calculation based on judged weightings of utility. Utility in this sense is some good, whether it's uh, monetary value, social value, whatever. Subjective probability, so calculation of estimated likelihood. These are things that we do, not very well, but we do them. Another theory here is prospect theory. This came out of Kahneman and Tversky's work. So risk aversion, that's spelled wrong too. I promise I didn't spell all this stuff wrong. Something changes when it comes over. So risk aversion in choices involving sure gains and risk seeking in choices involving sure losses. So this is how we kind of understand this process where when losses are sure, we take we start to bridge into risk seeking behavior. But when gains are sure, we get more risk averse. This can be a common, if you're thinking about this and you want a way to understand it, if losses are sure, let's think the lottery. That's been big in the news lately. Typically, lottery players are low income, right? So they may have less to lose. They're more interested in risk seeking for a small potential of gain. So, but then when you get the gains, right, the idea is you should become more risk averse to sustain the gains. Anyway, that's one of those options. And I'd say, behavioral economics is a big one. It's an entire field that kind of looks at this stuff. I often joke behavioral economics is economists discovered psychology because psychologists have been talking about these kind of trade-offs for a century or two. Anyway, then we go into naturalistic decision-making models. Now remember, this is some version of descriptive, but typically is about larger tasks and expert populations, more complexity and more nuance or steps. So we consider more realistic decisions made within the context of a larger task. So we're talking about time pressure, uncertainty, goals that aren't well defined, different high stakes, if we're looking at medical, paramedic stuff, high stakes falls in there. So the four essential naturalistic decision-making characteristics are: we focus on cognitive process, they judge alternatives in terms of reaching the goal, as opposed to just versus comparison, to an A versus B comparison. So this isn't a comparison of instances separated from the context of a situation. This is the comparison of alternatives within how do we reach this goal. You're typically looking at expert decision makers, not novices, and only realistic and feasible alternatives are considered by the expert. One of the biggest, if not the biggest, naturalistic models, recognition prime decision model, or you call it RPD. So it's an attempt to explain expert decision making under stressful and time pressure situations. It's typically based on satisficing. So satisficing is the least bad or the best worst option. We're comparing options until a suitable one, so something that will work with the least negative or the least amount of risk or whatever. We have three different phases. We're looking at situation recognition, serial option evaluation, and mental simulation. Of those, here we're going to change that to green, and we'll do that to purple. Okay, so situation recognition. We're really kind of in this space typically. Give or take. Remember, this isn't a hard and fast rule. Serial option evaluation, we're looking here. And it says mental simulation, but we're also evaluating. It's kind of, I suppose, if we wanted to be precise, we'd be looking at something more like this. So there's some overlap there. Then you step into the mental simulation space here. And then not listed here, but your action is there. So different decision-making methods. These are different than the models. The models are trying to explain all of decision-making. This is how we're actually doing that. So you can employ these methods within a model. Kind of weird, but it'll hopefully make more sense. So next graphic, we're identifying and choosing alternatives with the best value on the most important attribute. So, if we think about you're selecting courses to register for, right? What are your things that you are ranking your potential courses on. You might have, they meet a requirement, I have to have them for the degree, they seem fun, this teacher doesn't suck, whatever you're looking at, your lexicographic is that you're identifying what your primary value is, of those, and then that's how you're making your decisions. Satisficing, we talked about that. Um, Consider options one by one and select the first that is satisfactory. The first one that works, and that's what we're going with. Elimination by aspects. So this is essentially kind of could be like somewhat of an inverse of lexicographic, right? We're looking at, you eliminate alternatives if they fail to meet a minimum cutoff on an attribute. Group decision making or consensus. This is, groupthink. We could think of this as national politics, any organization by a large decision by a large body. Think about the CDC's COVID guidelines, right? That's an aspect of group decision making. Then we get into more naturalistic decision making, which we already walked through here, right? If you're going through all of these steps here, your naturalistic decision making there. It's a blend of intuition and analysis. You have to have some expertise for it to work. And you're working on satisficing and mental simulation. We're playing out the scenario with our decision in mind. So going into Kahneman's work, and we have to note he just passed away, I think, a week ago. Him and his partner in crime before, Amos Tversky, were incredibly impactful in really just all of psychology, and behavioral economics was largely born from them. So it's been really important, some of his work. This book I strongly recommend, just as it's a good read. And it includes some of their original articles basically edited for the book, and they're in there, but they do a really good job of explaining some of these things. It's part pop psychology, part memoir. It's interesting. So, thought and decisions operate within two different systems. This is their idea. System one, which is fast, system two, which is slow. And these are kind of some characteristics of those decisions. And we can all kind of think about this, right? You might have, your immediate response to shut a car door, for instance, if your finger happens to be in there, but you weren't aware. That's probably a system one thing. Versus, I know I do this when I'm about to walk out the door, I kind of pat myself down to make sure I have everything. That's a conscious, step-by-step rule following process. Here's some other characteristics, some pros and cons for systems 1 and 2. We won't go through all of them, but feel free to pause it if you want to really kind of reflect on this and dig into some of these aspects. There's pros and cons to both. There's reasons that you would do either. This, you also might start to notice there's some similarities between this and Rasmussen's work on skill-based, knowledge-based, rule-based stuff. Yep, that's where Rasmussen got some of those ideas, is from systems one, thinking fast and slow. So going back to some other decision-making methods, we do still employ trial and error in some situations, right? You might get to an instance where the stakes are too high or the risk is too great, where trial and error really isn't a good one. Algorithm, this is very common in procedural-based things. So we talk about nuclear power operations, or really any industrial operations that use procedures. They're using algorithmic decision making. They are going through a process step by step to get to the end. Then you have heuristics. These are going to be your guiding principles. This is how most of our decisions are made. For instance, we've talked about schemas. So if I walk into a store and I need to get into a line, I access a schema of what does one do when they need to get into a line at the store. How does this function? And we're accessing our memory for some set of rules or characteristics. Heuristics are the same thing here. They're just the decision-making side. So we get in the line because the schema tells us to. It provides a heuristic. These are mental shortcuts, and they are generally successful, but may not work. And they will also contain biases. Um, so no matter what, all of our schemas, all of our heuristics are biased in some way. That's understanding where those biases are. And it could be bias in the sense of like what we, more modern understandings of the term, where you're biased against some type of individual or some type of idea or something. But it could also be biased in favor of social grace, or biased in favor of practicality, or biased in favor of avoiding harm to yourself. Like, there's a lot of different biases there. Some are good, some are bad, but it's just something you have to be aware of. So the Linda problem, this was a famous thing that illustrates some of the heuristics that we use that can be problematic. So Linda is 31 years old, single, outspoken and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. Do you think Linda is a bank teller, or do you think Linda is a bank teller and is active in the feminist movement? And you need to rank the likelihood of each statement being true. This is typically the structure of the problem. Sometimes they'll include other characteristics of Linda and see how people rank the whole list. But this is kind of the foundational aspects. And the results overwhelmingly end up being a conjunction fallacy. So overwhelmingly, right here, literally 80% of the people that participated in this selected this option, which is a conjunction fallacy because the probability, as we weigh these, right, which ones has the greater probability, greater likelihood of being true? Joint probability, so the probability of statement A and statement B, cannot be greater than the probability of either of them on their own. And why is that? Because going back to stats, right? If we're trying to get the probability, let's call this A, let's call this B. This is statement X, this is statement Y. So the probability of A and B, that's not gonna work. That's the logical sign for and, but we'll do this. That looks like a B. And B equals probability of X times the probability of Y, which this isn't perfectly notated. This should be separated. This is a joint probability statement. So I'm going to fix that actually, because it's really going to look like this. Probability of X times the probability of Y. The probability can only at most ever be 1 if it's 100%. Usually it's a decimal. Multiply two decimals, you always get a smaller decimal. So anyway, now why does this happen? So looking at this, 80% of people, including statisticians, picked the first option, including statisticians that are trained in how joint probabilities work. Why? And typically the problem is the representativeness heuristic. So when we get into representative, we're making judgments about the probability of an event under uncertainty, or judging a situation based on how similar the prospects are to the prototypes the person holds in his or her mind. I'm going to go back a little bit. When you're employing the representative heuristic to make a decision, what you're using to get here has nothing to do with probability. You're using this. You're reading this, and again, because we're humans, we anthropomorphize everything. We also anthropomorphize in the sense, or we recognize anthropometric realities of other people. So when we're reading this, you are forming a representation, a prototype of Linda in your head. And the way this is framed aligns, or it could be argued, aligns well with this statement. And that's what you're doing. But it is illogical, and it is poor decision making in that sense. But, or is it? There are a lot of instances where representativeness, you form a, hey, I'm going to give you some characteristics of a person, and you tend to get it right a lot of time, but you have to be aware because those heuristics, they're generally applicable, but they may not work. Another heuristic is availability. By the way, there's a huge list of these. You can look them up if you need them, but these are the big ones. Judgments about the probability of events by the ease with which examples come to mind. So this is the likelihood you'll select a solution increases based on its recency of your recollection. So whichever one you get to first has more weight. Anchoring and adjustment, so tendency to rely more heavily on the first piece of information offered when making decisions. Escalation of commitment, so continued investment in a decision based on the cumulative prior investment, despite new evidence suggesting that the cost starting today of continuing the decision outweighs the expected benefit. This is also the sunk cost fallacy, right? You can't get sunk costs back. So in that essence, they should not have a bearing on your current decision. But a lot of people will say, well, we've already invested X amount in doing this, so we're going to keep it up, even if that method or process or decision was faulty to start with. And here's just a question just to kind of consider, are heuristics and biases top-down or bottom-up? Remember, top-down and bottom-up processing are the way that let's frame it like control or power exists in your brain. Either bottom up, so your sensory processing and stuff is making decisions, and or it's having more control over your top level processing, or vice versa. You're doing a top down thing where you're establishing rules at the top level in our higher order cognition, and then we're enforcing those rules downward towards our sensory processing disorder or sensory processing aspects. And then when we think about it, right, this is just, again, something to think about. Top down or bottom up, which is harder for human error? Which one do you think is more likely to cause human error? Something to maybe put in the Slack if you want. Some other heuristics, the contagion heuristic, this is recently relevant, right? Avoid association with others that are viewed as contaminated. This can be physical contamination or mental contamination, whatever somebody reviews. It's basically an aversion to a group characteristic. Naive diversification, so this is when making several choices at once. You diversify more than when making the same decision sequentially. You'll just over-diversify for seemingly no reason. Effort, so the worth of something is determined by the amount of effort taken to get it. And framing. Framing is a huge one. Whether a question is framed as a gain versus a loss would influence individuals' risk preferences when collecting information and making decisions. This is basically how every headline ever works. Now looking at failures, right? So human errors. What do descriptive theories say about human errors? They'll ascribe failures to heuristics and decision processing breakdowns. The framing is a big issue, and it can change the difficulty to identify a plan or solution. They assume, right, there's a well-structured plan, then there should be a clear path toward a solution. That's if you frame it in that sense, right? If it's an ill-structured framing, then there might not be a clearly relevant path toward a solution. You might be dealing with irrelevant information and require seeing the problem differently in order to solve it. Or you have an isomorphic problem. So this is also, I see this as a validity versus soundness aspect, but the formal structure of the problem is the same, but the content differs. And that can also be an aspect that drives it down. What do naturalistic theories say about failures of decision making? So they'll ascribe failure to a larger context, just as they assume decision making at a larger context. So training, experience, organizational factors. You might have incorrect goals. This could be a rule-based issue, right? Similar, internal pattern matching fails. So this is mental model struggles, different things like that. You also can compare these against like slips and mistakes if you want. And then cognitive biases, so confirmation, availability, framing, whatever. So then we get to an incorrect mental simulation or evaluation of options. So we have an inaccurate portrayal of the action, or the alternatives are included incorrectly. And so these are all kind of how they frame human error. Now, notice when we talk about descriptive theories, also an important thing to remember is they're also just explaining what happens. And then we try to figure out why it happens. But again, it's a descriptive theory. It's not saying it's wrong or anything like that. It's just explaining what happened. Also notice we don't talk about normative theories here because a normative approach to a human error would be stop it, don't do that again. It's how you ought to act. Now we could then, and this is an instance when we're trying to assign blame in the sense of a human error, we might look at why the decision was made in that way and how should it have been made if that person was aware, etc. So when we're looking at fallacies are a specific thing that's a failure in our internal logic, and there's a whole bunch of formal fallacies, informal fallacies. Again, if you're interested in that, take a logic class or Google them. So negative or positive transfer, solving an earlier problem makes it harder to solve a later one, or maybe it makes it easier. That's a odd kind of fallacious argument there. Functional fixedness, so the tendency to perceive an item only in terms of its most common use. You're only thinking about its function, you're not thinking about other approaches, right? This is whenever you've had your mind blown because somebody used something in a way you didn't ever think of. That's what's going on. Mental set or mental model here, persist in past problem solving strategies and assuming unnecessary constraints. Now, this is a huge one that we do all the time where we unnecessarily constrain our actions. And this is an example here, right, of a unnecessary constraint in the sense of, well, I can just do this how I want. 1, 2, 3, 4. Oh, I didn't get to it. Oh, well, I just did it. But, depending on the situation, you might be testing certain things. These kind of puzzles I can never do successfully, so I will not try here. And that's the end of that. I want you to just kind of reflect on this as it relates to all the other stuff we talked about, and see kind of how it all ties together. And if it doesn't, if you feel like it doesn't, it's still not super well connected, then let's talk about it. I'll put it in Slack and we'll have a back and forth there. So either way, hope you guys have a great weekend.